All right, great. Hello, everyone. So this is our second Tech Talk today, and we have Ramesh Raskar, who is an associate professor at MIT Media Lab and directs the Camera Culture Research Group. His focus is on AI and imaging for health and sustainability. They span research in the physical, digital, and global domains. He has worked on special research projects at Google and Facebook, and has also co-founded or advised several companies. He has received numerous awards, including the Global Indus Technovator Award in 2003, the TR 100 Award from MIT Technology Review in 2004. In 2009, he won the Alfred P. Sloan Research Fellowship and the DARPA Young Faculty Award. In 2017, he won the ACM SIGGRAPH Achievement Award, and in 2016, he won the Lemelson Award. So let us welcome Ramesh Raskar to the stage for his Tech Talk.
Thank you. It's wonderful to be here. And let's talk about COVID-19. It's a crisis of our generation and how we can use a digital response for COVID-19, from contact tracing, testing, vaccines, and so on. And how do we do all of that in a privacy-preserving way? Privacy-preserving machine learning with techniques such as split learning. So I encourage you to go to pandemic.mit.edu. I'm an associate professor at MIT Media Lab, and I'm also founder of a MIT spin-off PathCheck Foundation. So please join our Slack channel on tiny.cc/PathCheckSlack. Now, some of you know about Burning Man. I was at Burning Man, a few years ago, and I saw this booth, a telephone booth, old style, that said "Talk to God" on the playa. First of all, would you pick up the phone and talk to God on the other line of the call? Kind of very curious, right? Without getting religious about it, a lot of people would pick up the phone and ask about, some challenges they have, or they would be very skeptical about if God really exists. Well, if, a couple of years ago you had been at Burning Man and picked up the phone, the God on the other side of the telephone line, had a strong Indian accent, and that was me. So for several days on the playa, I was answering these phone calls, and people would come on the calls and share some deep secrets and deep challenges they're running into. And what I realized is that when they're on the phone call, although they probably realize that it's not really God on the other side, they're hoping, they are wishing there is somebody who is an honest, impartial broker, an omnipresent, omniscient entity who could just listen to what they're saying in a very confidential way, and maybe also in a confidential way tell the other entities who are part of the problem and bring those together like an honest broker. And so this experience really changed me as a human being, but also as a scientist. And so when I came back to MIT, I said, maybe that's what we need. We need this honest, impartial broker, a newfangled AI that can coordinate everything that's going on with this God's eye view, this bird's eye view of all the whole world. And clearly your reaction will be, no, that's not good, because that's exactly what a surveillance state or a big brother looks like. And that's not a good thing either. And if you look at our technology companies, some of them do have this bird's eye view, but we have kind of lost trust. We have a lot of faith. We have lost faith in these very large entities that have very deep view, very invasive view of what we do. So the challenge seems to be, we want to create this honest, impartial broker that's omniscient and omnipresent. At the same time, we don't have trust. So how can we create a very impartial broker who we can rely on, even if we don't trust kind of instinctively? And if you're a Nicolas Cage fan from National Treasure, this all-seeing, all-knowing eye of the Prometheus is what the story is all about, and it makes us feel very uncomfortable that there's this all-knowing, all-seeing eye. So if you think about this challenge we have of utility versus privacy, this trade-off, Google Maps is a good example where we willingly give away all our GPS information, and in return, Google gives us this amazing map with traffic information, the reds and the greens. So you get a lot of utility out of it. On the other hand, for something like health data, we really care about privacy, and there are a lot of regulations, and there is no way to share that data. And because of that, we get very low utility. The question is, can we combine the two? We get great privacy and great utility. And that's what a private AI could look like. That's an honest, impartial broker, this benevolent AI. And some of you might say, hey, you know what? Just like Google Maps, I give away my location. I really have nothing to hide. And what's the big deal if I give away all the information and then we get great services in return? But it's not just about an individual. It's about our community, and it's about a larger world that we live in. So even if you individually may not care about privacy, your community and where you live may actually care about it. Let's take an example of Strava. Now, many of you probably use Strava for keeping track of your outdoor activity, hiking, biking, running, and so on. And Strava publishes the heat maps, anonymized, aggregated heat maps of everybody's trajectories. Now, even if it's anonymized and aggregated, it ends up revealing a lot of information. So in this case, the map of Taiwan actually reveals the people who work in very confidential nuclear facilities and how people go from those facilities to their homes. So it shows the home locations of people who work in those nuclear facilities. Or in some cases, Strava heat map reveals the front bases of the US Army in Niger and Syria, because Strava is used mostly by Westerners, and as the Army men and Marine go for a jog around the American bases, US bases, those get very nicely highlighted. So even secret bases in Nigeria and Syria were outed by this Strava heat map. So again, sometimes it's not about the privacy of the individual or the community. In this case, it's even national security. So as you can imagine, user privacy may be about your device, but when it comes to health data, the lack of sharing of the health data could also be because of regulation, like HIPAA regulations in the US. Or if you have a data set or a biobank and you want to share data, you may not be able to do it because it's trade secrets, because if you share the data, that's worth millions of dollars and you don't want to give it away. So for one reason or another, we have this invisible data, and there's a lot of friction in sharing the data. So when I use the phrase privacy, I really mean any reason, whether it's privacy of an individual or an organization or even a nation, that prevents us from sharing this data. Now let's think about the current epidemic. If you think about other crises like hurricane, then we use two main things to overcome hurricanes. We have a bird's eye view, a God's eye view, which is literally a satellite. And then we have historical models. And with those two things, we can create a top-down solution of how people in the Florida Panhandle or in Louisiana this week should deal with the incoming hurricane. Epidemics, on the other hand, are slightly different. It's innocent people infecting other innocent people. And so you can't just have a top-down solution, and we have to use people themselves as sensors and emitters. And this is where smartphones can play a very important role. And we want people to self-organize and self-coordinate. And that's why we need a bottom-up solution. So that's why we have to think about this in a very unique way. And the moment we start using information about people as of information about the hurricane, privacy plays a very critical role. So I'm going to talk about a few areas of research that could be very interesting to you, and something that you, as a budding researcher, could jump in right now to deal with this crisis of our lifetime. So first one is exposure notification and case management, which is use the smartphone to understand proximity between people. Second, you notify if you're crossed paths with someone. And third is provide a public health and business coordination tool. And if you can do this with a lot of privacy and speed, that'll be great. So you may be familiar with the Google Apple exposure notification protocol that's based on Bluetooth. That's one way to do it. But there are other ways to handle GPS data or Wi-Fi MAC addresses to create similar solutions as well. Now, even if you create such an app on a smartphone, we want everybody to use it. It needs to have a viral adoption like Pokemon Go. The benefits are a little bit vague. The doubts about privacy and that we've deployed by public health. So it feels like an impossible app. Like, why would people download this app to get going? So we launched a nonprofit out of MIT called PathCheck Foundation, and exactly we're trying to resolve this problem. So we created a customizable app that's based on open source platform and also a scalable server that's also based on an open source system. And it's already available in App Store and Google Play Store, and it has become the world's largest open source GitHub architecture. So PathCheck Foundation, privacy first, MIT spinoff, it's helping many nations and states launch their exposure notification and case management apps. It has become the world's largest nonprofit open source organization, and it's really committed to a sustained innovation. It's not just about launching an app, but a sustained innovation as we go on. And we have hundreds of people working full-time, contributing to the software, working with jurisdiction, and the PathCheck app is already in 5 US states and territories, as well as multiple nations. So it's not just a do good project, but it's actually on the ground. And we also have millions of dollars in funding. So I'm delighted to have some serious professionals who have stepped up to become a professional team behind this foundation. And at the same time, in addition to software, the foundation also publishes a lot of research papers, analyzes open standards, interoperable standards, and publishes them in real time, and also provides, professional management, because we're talking about really talking about health in this U.S. states and nations. So it's a professional organization that also delivers the app and maintains the servers. Now, if you think about an experience of an individual, there's exposure notification, but there's also triaging, testing, quarantine, exiting from the quarantine. It's a pretty complex process, and any large software company could come in and just deploy this solution. But the challenge is, how do you achieve all of this in a privacy-preserving way at every stage? Without asking for your name or email address or phone number or a national ID number, how do you manage all of this so that anybody in any country, even if they don't trust the government, even if they don't trust, the law enforcement, even if they don't trust their own employer, they should be able to participate in the system and get all the benefits of exposure notification, which is avoiding other people who either avoiding or getting an early alert if they have crossed path with an infected person, getting tested without revealing their identity, get those tests and demonstrate that they're safe, quarantine if they're not able to get the test, and exit as well. And case management, the manual case management involves 3 steps: contact tracing, triaging, and monitoring. But digital one is all self-guided: exposure notification, self-assessment, and self-monitoring. And what we're doing at PathCheck Foundation is really bringing those 2 together. So let me play a quick video to give you an idea of how this works. After possible exposure, there are 4 steps for manual contact tracing for case management: analyze context, send for test, self-isolate, or exit from that isolation. The user can see exposure history and the details, take self-assessment, see if they remember where they were, they're wearing a mask, if they're maintaining social distance, if they have new symptoms, or they have some existing conditions. If they're over 65 or pre-existing health condition, and decide the next steps: test, isolate, or wear mask, enter a zip code, get a random ID that can be used as the case management number, completely anonymized, or chat with PHA, and upload this anonymous data or inform exposed contact, and decide what to do next. Find a testing location, for example, see the map, schedule testing. Once tests are available, positive or negative, see the tests in the app, and go through the steps we saw earlier as before, again with case management number or chat with PHA. Upload this data and inform exposed contacts. If the symptoms indicate you're in green zone or orange zone or red, when it's red, contact your health authority. More importantly, the public health on a dashboard can see all these patients and their case management and their current status, green, orange, or red. The individuals can go into self-isolation. We can ask them questions about if they can live in a different house or isolate for 14 days. You live with an at-risk individual. Decide the next steps, as we saw earlier. At some point, after 14 days, the self-isolation is complete. Decide what to do next and say recommendations. So that gives you the idea of the type of software you can use to really, really tame this pandemic. So, at MIT, we are writing many research papers, and as I said, we have about 2,000 people on our platform, on our Slack channels, who are writing papers, writing code, creating policies, working with different states and nations working on this. So if you're welcome to participate. And the question really is on this call is, as an undergraduate researcher, what can you do right now to truly do something about this pandemic? And foundations like PathCheck or others are a fantastic platform. Now, coming back to privacy, the challenge was we thought of statistics as taking human data and coming up with meaningful information in an aggregate manner. But the problem in today's world is that privacy is using that aggregate data to go back and target information about an individual. And it's getting more and more precise. So it feels like precision is the first enemy of privacy. So if you can somehow reduce precision, you can get away with it. So a few techniques have emerged, right, for doing that, like differential privacy. But let's look at some other problems. Like if you look at COVID-19 chest X-rays, there have been about roughly 2 million hospitalizations, but the largest data sets have only about 14,000 chest X-ray images. And so any machine learning models that you train on such chest X-rays are just incomplete. So it will be great to create privacy-preserving or trade secret-preserving machine learning that will take this 2 million X-rays and build the next best machine learning model. So the challenge here is, again, the privacy versus utility trade-off. If you want to train deep neural networks without exchanging raw data on the phones or questionnaires and sensors or video or audio or diagnostic information like chest X-rays, then you get this trade-off. You can use anonymization like Strava has, but that's no privacy at all. It's anonymization, but not privacy. Or you can obfuscate, like we saw in case of precision, add noise with differential privacy, or you can encrypt with techniques like homomorphic encryption. But the challenge is as you go to the right, you cannot do full-fledged machine learning of models. So two techniques have emerged over the last few years. One is called split learning from MIT, and another one is called federated learning from Google. And that allows you to create this privacy-preserving AI. And the idea in both these techniques is to share wisdom without sharing raw data. And the overall concept here is collective intelligence, which is although each site, each phone, each hospital can only partially train what's going on with the limited data set, all these partially trained machine learning models can collectively create, the global AI that's better than any one of them. So to fight COVID-19 and restart economies, we have to think about individual users, public health, employers, and services like tourism. We have to solve problems like exposure notification and symptom tracking and use privacy-preserving machine learning techniques that can take this information for testing and vaccines and care and cure. Nevertheless, to solve all these problems, we need really talented people working nonstop to solve this, because the pandemic is new, the types of problems we're facing are new, the algorithms are not robust yet, and many new algorithms had to be created to manage this. So, next time we get this opportunity to talk to God, I think it's really the new God, which is a newfangled AI that's privacy preserving. And if we can use the privacy-preserving AI, then we can use techniques like split learning and contact tracing to really deal with pandemic. So I encourage you to sign up on pandemic.mit.edu, join our Slack channel, tiny.cc/pathcheck Slack, or just email me if you would like to join this movement, a software-based movement, a digital response to the pandemic. Please download our apps or join the GitHub at the PathCheck Foundation. Thank you.
Great. So if anybody has any questions, feel free to drop them in the chat. We do still have some time left to answer any questions.
Yeah, you're welcome to post the link in the chat page as well. It's tiny.cc/pathcheck Slack if people want to join this movement to write software during this pandemic.
Okay, it seems like there's a question in the stage chat. It seems like a big motivation for PathCheck is to mitigate the effects of COVID, but do you have any ideas of applications after COVID is controlled?
That's a very good question. So I think COVID-19 is a kind of a wake-up call for us to deal with, anything that involves social activity. But whether it's climate change, whether it's transportation, whether it's social unrest, even democracy, all of these problems require us to self-organized, self-coordinate, and this orchestration cannot always be done by big tech companies or governments. And we have seen how they fail miserably when you have this top-down orchestration. So, definitely for pandemic response as of now, but also pandemic preparedness, we need these privacy-preserving orchestration techniques. But going forward, we would need them for any other crisis as well. And the fact that we are creating privacy-preserving machine learning for these challenges can also be used for other slow-moving threats, such as climate change. Because if we can all coordinate and understand what our impact is and share, what our needs are, what our challenges are, we might be able to do a lot of things. If you use Google Maps for Waze, it already allows us to coordinate without relying on city governments. We know which roads we should take or we should not take because they're crowded. And any other challenge we have in society, whether it's health or employment or poverty or climate, if we can see how things are moving along, we might be able to get a guidance for individuals. Looks like there's a question about if privacy preserving is double-edged blade, because people who are rational, but what if privacy being preserved is actually malicious? Someone who wants to deliberately cause harm, like spread COVID or commit a terrorist act. So that's a very good question. So in fact, it's the other part of dealing with this is actually looking for bad actors. So often when bad actors are on an online platform, they hide behind privacy. And you're absolutely right. There is a trade-off between privacy and safety of the society. So it turns out that many of these privacy-preserving techniques, look up our paper on splintering. And in splintering is actually possible to create a software that will validate locally if the content is harmful or inconsistent and flag it while maintaining complete privacy in an end-to-end encrypted manner. So yes, in fact, once it's privacy preserving, it becomes even more possible to monitor any bad actors in that sense. So that's really the beauty of this. In fact, some of the systems are already being used for looking for bad images or illegal images online, or flagging content that's being shared on private chat channels and so on. So privacy preserving looking for bad actors is indeed part of the solutions. So look up on our archive page on a paper on a technique called splintering. There's a question from Anant about, I believe Apple and Google made statements that they would not hold on to this data post-COVID. What is PathCheck's plan for what to do with data in the post-pandemic world? So first of all, Apple, Google, or PathCheck or MIT, we do not hold on to data at all. That's the beauty of this privacy preserving technique. And the data is either stays on the phone, or if it does leave the phone, you cannot reconstruct that data at all, unless you have explicitly consented to that information, such as your zip code or something like that. But nothing personally identifiable is actually doesn't actually leave your phone. And if certain public health governments who use our source code and launch their own solutions, they should have similar safeguards as well.
Okay, if you guys have more questions, feel free to ask them now. There will be a break from 3 to 3:30, and so we can keep on going with questions if you guys have any more questions.
Yeah, there's a Anant is making a asking for like reading more about split learning versus federated learning. And so just kind of a very high level explanation of split learning versus federated learning. So federated learning from Google, split learning from MIT. And the idea behind both is very similar, which is when you have a client and a server, the client has the data and the server wants to train a machine learning model. But the server is not allowed to look at the client data. In this case, client could be a phone and the server could be a public health server, for example. And so the way it's done is you either train a local machine learning model on your phone and send only the weights of the machine learning model, the deep neural networks models, to the server, and the server take effectively an average of those weights. That's the federated learning approach. The split learning approach is you convert every data point into an intermediate representation, which we call smashed representation, like a feature vector. And only that feature vector is sent to the server for either training or inference. So in both cases, the privacy of the raw data is preserved. And I'm not talking about just keeping privacy of the personally identifiable information, but any data at all. Fantastic. Thanks, everyone.
Yep. So there will be a break. And if you guys want to, you guys can go to the sessions tab. There will be a few rooms there if you want to meet other people during this break. Oh, and it looks like there is one more question. If you do want to answer, Professor.
I think there's a question about homomorphic encryption, and it seems counterintuitive that you can both encrypt data to prevent a malicious person from finding patterns, but at the same time feed it into an ML model that intrinsically looks for patterns of this data. Yeah, it's a very good question, and we as human beings do this all the time. If you know your friend for a very long time, then your friend might just do a quick gesture and you'll be able to reconstruct everything that you have done with that friend. It's like, oh yeah, that's the time we were in Paris and we were in this cafe and you said this and it was funny. And that you can get all of that by just a tiny gesture, because you and the friend, a client and the server, has reached some kind of an equilibrium in terms of your trained models. And then even a tiniest piece of information can be used by the server to reconstruct the whole signal, in this case in a privacy preserving way. So homomorphic encryption, of course, uses mathematical principles, either using eigenmatrices or encryption mechanisms to encode the information to get service from a untrusted server and bring the results back and look at his results. So you are right that right now homomorphic encryption and training of machine learning doesn't work very well together. So homomorphic encryption can be used for statistical questions or analytics, but not so well for machine learning yet. And so split learning and federated learning are a better mechanisms right now to do privacy preserving machine learning, but not homomorphic encryption. Thank you. Bye.